Good afternoon and welcome to Day 2 of Chapter 5, Section 7, Differential Equations. For this first example, we're going to show that this equation, y equals 4 times e to the x plus 5e to the 3x, is a solution to this differential equation. So the first thing I need to do is take the first derivative and second derivative of the original function that we're given. So the first derivative, or y prime, would be 4 e to the x plus 5 e to the 3x, but we need to take the derivative of this exponent using the chain rule, and the derivative of 3x is just 3. So our first derivative, if I want to simplify it just a little bit, is 4 e to the x plus 15 e to the 3x. Now, let's take the second derivative. So I need to take the derivative of our first derivative. So once again, the derivative of 4 e to the x is 4 e to the x. And then we need to take the derivative of 15 e to the 3x. And the derivative of 15 e to the 3x is 15 e to the 3x. But once again, we have to use that chain rule and take the derivative of 3x, which is 3. And so now I will simplify this a little bit, or multiply the coefficients together, and my second derivative ends up being 4 times e to the x plus 45 e to the 3x. So I have my first derivative, I have my second derivative, and now I need to show that this is a true equation by substituting the second derivative in place of y double prime and the first derivative in place of y prime. So let's do that. So our second derivative was 4 e to the x plus 45 e to the 3x. And then we have minus 4 times the first derivative. So I'll substitute the first derivative in place of y prime. I'll have 4 e to the x plus 15 e to the 3x plus 3 times y, I'll substitute this in place of y. So I have 3 times the quantity 4 e to the x plus 5 e to the 3x equals 0. So now I need to distribute and combine like terms, and hopefully we have a whole bunch of terms adding to 0 since this is supposed to equal 0. So distributing the negative 4, I have negative 16 e to the x, then minus 60 e to the 3x, plus 12 e to the x, plus, distributing the 3, 15 e to the 3x. So let's check to see what we've got here. Well, I've got 4e to the x here, and 12 e to the x here. Those add to 16 e to the x. And look, I have a negative 16 e to the x. So those terms would all add to 0. And let's take a look at our other terms. I've got a 45 e to the 3x plus a 15 e to the 3x. That adds to 60 e to the 3x. And look, here we've got a minus 60 e to the 3x. So those terms would also add to 0. So on the left side of our equation we have 0, and on the right side here we have 0. So we've just proven or shown that this equation y equals 4 e to the x plus 5 e to the 3x is a solution to this differential equation. Let's take a look at some other examples. So example 2 here. We're going to solve this differential equation, and we're going to come up with a specific solution since they've given us a value for x and a value for y. So the first thing we need to do is get all the y's on one side of the equation and all the x's on the other. Separate the variables. So let's do that. Let's begin by subtracting x from both sides. And then let's multiply both sides by dx. So I have 3y squared dy equals negative x dx. And so now I need to do the opposite of taking the derivative, which is to take the integral of both sides or take the antiderivative of both sides. And so on the left side, I'd add 1 to the power and divide by the new power, so I'd have y cubed. And on the right side, I'd add 1 to the power, divide by the new power. I'd have negative x squared over 2. And then, of course, we have our constant plus c. So let's figure out the value of c by substituting 0 in place of x and 5 in place of y. I'll do that over here. We'd have 5 cubed equals, well, this would be 0 squared over 2 plus c. So we'd have 125 equals 0 plus c, which means that c is 125. So let's substitute that back in place of c. So we'd have y cubed equals negative x squared over 2 plus 125. But really we want to have y by itself. So I'm going to take the cube root of both sides. So our final solution to this problem is y equals the cube root of negative x squared over 2 plus 125. And let's take a look at one final example. This one seems pretty easy. There's not a lot going on. But once again, we want to get the x's on one side of the equation and the y's on the other. So let's do that. We'll multiply both sides by y and both sides by dx. So I'm going to have y dy equals x dx. And then once again, we're going to do the opposite of the derivative to both sides. We're going to take the integral or the antiderivative of both sides. And so I'll have y squared over 2 equals x squared over 2 plus c. But I want to get y by itself here. So let me multiply both sides by 2. I'd have I'd have y squared equals 2x squared over 2 plus 2 times c. I need to make sure I multiply everything by 2. Well, but I can simplify this, so let's simplify that a little bit. We'll have, oh, and we need to get y by itself. Right now it's y squared, so we would need to take the square root of both sides. But remember, when we take the square root of both sides of an equation, we'll end up having plus or minus if this is a square root. We didn't have that when we had a cube root. There's only one solution. But here we have plus or minus because of the square root. Plus or minus the square root of x squared plus 2c. Sometimes you'll actually see this right here, which is a constant, rewritten like this. They'll say, let C1, you'll see this done in some textbooks, let C1 equal 2 times C. And then sometimes you'll even see this written out as two separate equations. So y equals the square root of x squared plus C1. Our textbook actually does this as well. And y equals negative the square root of x squared plus C1. You could really leave these together if you wanted to, plus or minus the square root of x squared plus C1. But we really want this just to look like one constant, and right now it looks like 2 times a constant. So a lot of textbooks, and this happens quite a bit in differential equations if you end up taking the course in college, they'll replace this constant with another one that they call C1. And if you had to replace a second constant, you replace that and call that C2. So the problems in the next homework assignment might have you doing some of this, so be sure to refer back to this example.